Now let us discuss about the other terms involved in thermodynamics. System. Note on this. System refers to the part of the universe in which observations are made. So system is the portion of the universe under investigation or under observation, right? Okay. Now, surrounding. It is the remaining space. So when we say surrounding, it includes everything other than system. For example, I am having a cup of tea. That is, tea is kept in the cup. Let us assume that alone is in this universe. Right? Now, the cup of tea, that is tea, is the system. The remaining space is surrounding. Are you able to follow? So, which distinguishes the system from the surrounding? There should be a boundary. And what is that boundary? Which is nothing but the container here. That is cup. Right? Therefore, the universe is equal to system plus surrounding. But, sir, you have system and you have surrounding. How do you distinguish this system from the surrounding? It is because of the boundary. So, boundary is also essential. Right? So, the wall that separates the system from the boundary is called, the wall that separates the system from the surrounding is called boundary. So, boundary, B-O-U-N-D-A-R-Y, boundary means the wall that separates the system from its surrounding. Now, let us consider the same tea. This can be kept opened in a cup. And in the second case, I have kept closed with a lid. I have put a lid on the tea, that is tea cup. Now it is closed. That is case B. And case C, the tea is kept in the vacuum flask. So these are the three cases. In the case 1, that is in the first case, this is called open system. Do you know why? Because there is a loss of mass. Is it not? After some time, when you weigh, there is a loss of mass. So since there is a mass transfer, the loss of mass indicates what? Transfer of mass. So there is a loss of mass. That is, mass transfer has taken place. And will it maintain that same temperature? No. It gets cold. So it means that is, yes, that is, heat is also transferred. So when a system experiences both mass transfer and heat transfer, it can be called open system. Got it? In the case of closed system, now I have put the lid over the tea. Now let us weigh after some time. There is no change in that, change in the mass. So it means there is no mass transfer. The transfer of mass is arrested by keeping the lid on the cup. Right? Okay. Then what about the temperature?
Heat transfer. Heat transfer will be there.
There will be a heat transfer. Okay. So it means there is a heat transfer, but there is no mass transfer in the case of closed system. But in the case of isolated system, now we have kept this. Let me say this is a very ideal, perfect vacuum flask. So in this case, there is neither mass transfer nor heat transfer. And therefore, Based on the nature of the boundary, we can classify the system as open system, closed system, isolated system. Now let me ask you some simple question. In which case there is no heat transfer?
Second case.
Second case or third case?
Third case.
Third case. Isolated.
Isolated.
Okay. In which case there is no mass transfer?
Second and third.
Second and third. In second case, that is closed system and isolated system, there is no mass transfer. In which case both transfer occur?
First case.
First case, that is open system. So the system can be classified as open system, closed system, isolated system based on dash of the wall,
Boundaries.
nature of the wall or nature of the boundary. Are you able to follow this? So the system can be classified into open system, closed system and isolated system. Got it?